Okay, so welcome back, and now we're going to do another example where we're going to take something that's in the Cartesian plane, a Cartesian equation, and we're going to transform it into polar form. Okay, so notice that this is the equation of a straight line. So what would that look like in the polar coordinate system? Well, this does not go through the origin, so the angle is going to change and the radius is going to change. So what would it look like? Well, don't know, but you can visualize it, right? Okay, so you think of a line that has a y-intercept of 2 that has a positive slope of 3. So it's going to be, we know that it's going to look something like this, right? So if we were looking at something that was changing, like a point that was flowing up and down here, the angle, right? If we had this, again, a ball tethered here, and it was going down along this line, the angle would change and the radius would change. So I'd be interested to see what that form looks like. So there's going to be a radius and there's going to be an angle for this one. So how do we do this? Well, let's use our substitution. Well, y is going to be r sine theta, so we'll just make that substitution. X is r cosine theta, so we're going to do 3 times r cosine theta plus 2. And now I'm going to solve for r. Okay, so I'm going to subtract 3r cosine theta from both sides. Okay. And so what do I get? I get r sine theta minus 3r cosine theta equals 2. And so what I'm going to do is I'm going to factor out the r. So that gives me r times the quantity sine theta minus 3 cosine theta, which equals 2. And then now I'm going to divide both sides by this. And my final answer is I get r equals 2 divided by the quantity sine theta minus 3 cosine theta. And that's the answer. Have a great day.